In this video, we're going to explore the relationship between C pointers and arrays. Understanding how these two concepts interact is crucial for mastering C programming. We'll cover how arrays are essentially treated as pointers to their first element. The illustration depicts a memory block representing an array. Each cell holds a value such as 10, 20, 30, 40, and 50. Each cell also has an index, starting from error of 0, error of 1, error of 2, error of 3, and error of 4. A pointer PTR is then assigned to point to the beginning of this array. In C, the array name error acts as a pointer to the first element of the array. Memory addresses such as 1000, 1004, 1008, 1012, and 1016 are shown to illustrate how elements are stored in memory. Let's dive into how an array name can be used as a pointer. Here's a simple C code snippet. We declare an integer array named ARR with 5 elements: 10, 20, 30, 40, and 50. Then we declare an integer pointer named PTR and assign it the value of ARR. Note that we don't need the ampersand operator here, because the array name ARR already represents the address of the first element. The code then prints the value of the first element using ARR of 0, *ARR, and *PTR. All these three methods are equivalent and will print 10. Here are the key concepts to keep in mind. The array name ARR is implicitly converted to a pointer to its first element. We don't need the address operator, ampersand, when assigning an array to a pointer. ARR of 0 and *ARR access the same memory location. Finally, the array name represents the base address of the array. Now let's explore how to access array elements using both array indexing and pointer arithmetic. Consider this C code. We have an integer array named ARR, initialized with 5 values. An integer pointer named PTR is also initialized to point to ARR. The code then uses printf statements to print the first 3 elements of the array using 3 different ways. First is array indexing using ARR of 0, ARR of 1, and ARR of 2. Second is pointer arithmetic using *PTR, *PTR, plus 1 parenthesis, and *PTR plus 2 parenthesis. The third method uses the array name as a pointer using *ARR, *ARR, plus 1 parenthesis, and *ARR plus 2 parenthesis. All 3 methods are equivalent and will produce the same output. The diagram illustrates how array elements are accessed. The top row shows the array ARR with values 10, 20, 30, 40, and 50. Below it, error of 0, error of 1, error of 2, error of 3, and error of 4 are shown. Then, *PTR, *PTR plus 1 parenthesis, *PTR plus 2 parenthesis, *PTR plus 3 parenthesis, and *PTR plus 4 parenthesis are displayed. As alternative notation, *ARR, *ARR plus 1 parenthesis, *ARR plus 2 parenthesis, *ARR plus 3 parenthesis, and *ARR plus 4 parenthesis are shown. The memory addresses are given as 1000, 1004, 1008, 1012, and 1016. To summarize, ARR of I is equivalent to *ARR plus I parenthesis. The compiler translates array indexing into pointer arithmetic internally. It's important to understand the key differences between arrays and pointers in C. Let's look at some code that highlights these distinctions. We declare an integer array named ARR with 5 elements and an integer pointer named PTR, pointing to ARR. The code then prints the size of ARR and PTR using the sizeof operator. For ARR, it outputs 20 because there are 5 integers each taking up 4 bytes. For PTR, it outputs 8, which is the size of a pointer on a 64-bit system. One important thing to note is that arrays cannot be reassigned. Trying to assign PTR to ARR will result in a compilation error. Here's a summary of the key differences. The size of operator returns the total size in bytes for arrays. For pointers, it returns the pointer size. Arrays are not assignable. You cannot change what an array name points to. Arrays are fixed at compile time, while pointers can be dynamically allocated. Array names are constant pointers that cannot be incremented. Arrays automatically allocate memory. Pointers need memory to point to. Let's delve into how pointer arithmetic can be used to traverse arrays. We have an integer array named ARR with 5 elements. An integer pointer named PTR is initialized to point to ARR. The code then shows 2 methods to print all the elements of the array. The first method uses array indexing. A for loop iterates from =0 to 4, printing ARR at each step. The second method uses pointer arithmetic. Another for loop does the same, but this time it prints *PTR plus I parenthesis. The diagram illustrates how pointer arithmetic works. The array ARR with values 10, 20, 30, 40, and 50 is displayed. The memory addresses are given as 1000, 1004, 1008, 1012, and 1016. A red box moves across the array, representing the pointer PTR being increment. It labels PTR, PTR plus 1, PTR plus 2, PTR plus 3, and PTR plus 4. Dashed lines connect each pointer position to the corresponding array element. Some pointer arithmetic facts to remember. PTR plus 1 adds size of parenthesis, int parenthesis bytes, which is 4 bytes. The compiler handles the scaling based on the pointer's data type. Let's explore some practical applications and summarize what we've learned. Arrays are commonly used as function parameters. Here are 2 functions, printArray and printArrayPTR, which both do the same thing, that is, print an integer array. The first function, printArray, takes an integer array ARR and its size as input. The second function, printArrayPTR, takes an integer pointer PTR and its size as input. Both functions can be called in the same way, using the array name and its size. Here are the key takeaways from this video. Array name decays to a pointer to its first element. Both arrays and pointers can use indexing syntax like ARR of I and PTR of I. Both can use dereferencing, like *ARR plus I parenthesis and *PTR plus I parenthesis. However, arrays have fixed size at compile time, while pointers can be assigned different memory locations. Thus, arrays cannot be reassigned. Also, the size of operator behaves differently for arrays and pointers. When using arrays as function parameters, they are always passed as pointers and the size must be passed separately. Therefore, int ARR of bracket and int *ARR are equivalent in parameters. Some best practices to keep in mind. Use array notation for fixed collections. Use pointer notation for dynamic memory. And always check bounds to prevent buffer overflows. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.